Today we're going to look at the law of sines. Now, we've been talking about all of the trig ratios, and when you use your trig ratios, you use them for right triangles. But you can also use trigonometry to solve what we refer to as oblique triangles. And an oblique triangle is just simply a triangle that doesn't have a right angle. Okay, so in order to solve an oblique triangle, you must know at least one side. And any two other parts. So the first two that we're going to look at today, or there's technically three scenarios that we're going to look at today, and the other two we'll look at tomorrow. Both of the ones that, all three of the ones that we look at today, you're going to be given either two angles and a side or two sides and an angle. So what that looks like, if you think back to geometry when you first learned about triangle congruence, if you're given two angles and a side, and that side is not included between the two angles, then you would refer to this as angle side. So it would look like this. So I have two angles and a side that's not between those two angles. So this would be angle side. And then you can also have two angles and the included side. And that will look like this, where you have your two angles and the side between them. So this is going to be angle side angle. And then the last case we'll look at today is what we refer to as side angle, even though you're not allowed to have that with congruence. And so this is when you're given two sides and the non-included angle. So what that looks like in a diagram is I know this side, and I know this angle. And so we refer to this as SSA, because if we write it forwards, then that's not appropriate for the school environment. So side angle, and we often refer to this as the ambiguous case. And we'll talk a little bit more about that in a few minutes. Okay, the ambiguous case. It's a special scenario that occurs. So we use the law of sines to solve any of these three types of situations. And your law of sines is it states if you have an oblique triangle, it doesn't have to be a right triangle, any oblique triangle, and you know that your vertices are A, B, C. The sides opposite your vertices are going to be your side lengths. So this is going to be little a, little b, and we'll call this little c. Okay? And what your law of sines says is if I take little a over the sine of angle A, well, that is equal to little b over the sine of little b, which is also equal to little c over the sine of c. So let's get through a couple of examples with this. So let's say you are given, we'll do the angle side scenario. So example number 1, let's say with our angle side scenario, we're told that the measure of angle B is equal to 28.7 degrees. The measure of angle C is equal to 102.3 degrees, and side little b is 27.4. Solve for A, the measure of angle A, little a and C. So what you're trying to do is solve the triangle. So to do that, the first thing you should do is just draw a picture, sketch a real quick picture, label it ABC. It doesn't have to be drawn to scale. We know that angle B is 28.7. We know that angle C is 102.3. We know that side little b is 27.4, and we need to find little a, little c, and the measure of angle A. So to find the measure of angle A, well, that's pretty straightforward. We just subtract the other two angle measurements from 180. So I subtract 28.7 and 102.3 from 180 degrees, and that's going to give me the measure of angle A to be 49. So using the law of sines, now I can find my missing side lengths. So I can say little a over the sine of 49 is equal to 27.4 over the sine of 28.7. Little b over sine of b. And so when I solve this for a, you're going to solve this as a proportion, so you're going to cross multiply. So a is equal to 27.4 times the sine of 49 divided by the sine of 28.7. And so I plug this into the calculator and I let it do all of the fancy legwork, and this is going to give me approximately 43.1. And then in a very similar setup, I'll do the same thing for side little b or little c. So I have little c over the sine of 102.3 is equal to 27.4 over the sine of 28.7. So little c is equal to 27.4 times the sine of 102.3 over the sine of 28.7. So my little c is going to be equal to approximately 55.7. And then for example number 2, we'll look at an angle side angle case. So we have, I'll give you a diagram this time. We know that we have this triangle A, B, C. And the measure of angle B is 98 degrees. The measure of angle A is 43 degrees. Find little a, little b, and angle C if you know that little c is 22. So the measure of angle C is going to be 180 minus 98 and 43, which gives me 141. So this is going to be 39 degrees. And then to solve for A and C, I use my law, A and B, I use my law of sine. So I have A over the sine of 43 equals 22 over the sine of 39. And then the same thing for B, I have B over the sine of 98 equals 22 over the sine of 39. And this will give you A is 23.8 and B is 34.6.